If a large object is heated by an amount equal to 20 joules, but the object is sufficiently large to maintain a temperature of 15 degrees Celsius, by how much did the object's entropy increase? Now, the formula we have for entropy change is delta S is equal to Q over T. It's good that it says there that the temperature is going to be constant, because that leaves it unambiguous what we're going to put in here, except maybe for the fact that we could ask the question, should we keep it in Celsius or in Kelvin? I haven't addressed that yet. And one way of looking at it is, what if the temperature had been 0 degrees Celsius? That's definitely not absolute zero, and therefore a quite viable temperature, and it corresponds to what usually the temperature on Earth where water freezes. If you put that into that formula without converting to Kelvin, you'd wind up dividing by 0. That's a clue that maybe that's not the thing to do. So yes, we want to put that temperature into Kelvin. The other part that we discussed on the key concepts slide was the fact that this heat had to correspond to a reversible process. Now, in this case, it turns out that's pretty easy to argue, because if we simply argue that this process happened in a way that the object is in thermal equilibrium with the environment that is heating it, that doesn't have to be what really happened. But as long as that seems like a sensible thing, then we can use that. And it turns out, regardless of what temperature the environment is at, this object received 20 joules of heat. And that's good enough, it turns out. So what that means is we can just plug into this formula the 20 joules that we're given for the heat. And then for temperature, that 15 degrees Celsius should be converted to, let's see, plus 273.15 would give us 288.15 Kelvin. And so then that is a number that I think most of us will want to turn to a calculating device on that, unless you really like doing arithmetic, I suppose. And my calculating device says 0.069. I don't know why I'm writing it that high up on the board there, but 0.0694, and I think 3 significant figures is probably good enough. And looking at the units, this should be joules per Kelvin. That is the customary unit for an entropy change. So that is the entropy increase in this case, and it checks out with what the slide says.